This is a short film of the AutoFlood autonomous flood irrigation system deployed on a 65-acre Klein grass field near Holtville, California. AutoFlood is all about retrofitting automation to the existing irrigation infrastructure pervasive throughout the Desert West. Installing AutoFlood will save roughly 90% of labor costs and conserve approximately 10% of required water. We are looking downstream on a typical on-farm canal fit with 24 small pipe gates controlling irrigation flow onto a field that is divided into 12 5-acre lands or field segments. Each land is flooded in sequence by opening 2 pipe gates. Prior to autoflood, the pipe gates were manually operated over 2 to 3 days by lifting a bent wire handle attached to its blade. AutoFlood replaces the manually operated blade with a solar-powered electronically controlled assembly. We're now looking upstream on the canal, near the center of its length. Notice the solar-powered hub or master station in the center of the screen. The hub is in radio contact with each gate, taking station data and sending commands as needed to sequence irrigation. It is also in near continuous contact with the internet via cellular modem, updating display software available to farm management. Note irrigation flow passing through an open pipe gate. Water passes through the pipe, heading across the land towards the drainage ditch where excess flow is sent off-field. Halfway down the field is a water present sensor that alerts the hub that water has traveled that distance, so the hub can calculate its unique transit time for that day and predict the additional time necessary to complete the watering. Looking downstream again, we see a check gate, also controlled by autoflood. Check gates are used in canal to check up or raise water levels as high as possible without overflowing the canal, so maximum hydraulic forces push flow as fast as possible through each pipe gate. This is especially important on alfalfa to prevent scalding during summer. AutoFlood takes data from a level sensor upstream of each check gate and uses it to manage canal levels. Level data is also used to initiate a canal overflow protocol that opens downstream gates to discharge excess flow if water deliveries exceed canal capacity. Overflow management is also essential on farms with varying numbers of gates per land. Moving to the end of the land being irrigated, we can see its drainage ditch. The ditch is in place to collect excess flow, transporting it off-field to much larger drainage ditches. When this field did not have autoflood installed, the ditch would be completely full, looking more like a long pond than a ditch. Notice the vegetation on the right bank of the ditch, which indicates how high water level would normally get without autoflood. Farmers in the Imperial Irrigation District pay $20 per acre-foot of water delivered to a field. They are paid $285 per acre-foot for water they can demonstrate was conserved based on prior usage. On this field, we demonstrated 7 to 12% conservation over various waterings. An average 10% savings would net the farmer $12,000 annually on this small field. Autoflood will pay for itself in 4 to 5 years based on water conservation alone. Including labor savings, shortens payback to 2 to 3 years.